Today's class we shall see the relative velocity in two dimensions and projectile and velocity components along x and y directions and motion with a constant acceleration in two dimensions and simple problems we shall see in this class. Now, relative velocity in two dimensions. In the last chapter, you had seen the relative velocity in one dimensional. Now, if you consider the relative velocity two dimensions, what happens? Let's say a frame of reference. This is called velocity of A in two dimensions, and this is the velocity of B in two dimensions. The velocity of A relative to B, or we can write it as with respect to B, VAB, which is written as VA minus VB. Similarly, velocity of B with respect to A, we should write it as VB minus VA. So, simply I can write that velocity of A, what is mean? It is respect to earth, most of the values with reference to earth only. Now, the reference platform we have taken it as our XY reference frame, and most probably we shall travel in the train, and if the train is going with a speed of 40 kmph, we are assuming that we are moving 40 kmph. With respect to train, we are at rest. With respect to the earth, our speed is 40 kmph. Relative speed with respect to the train cabin or whatever bogie is 0. Now, I think you have seen all the terms in the last chapter. Now, the mod of VAB, which is equal to mod of VBA, magnitudes remain same and opposite direction. Let us say VAB, which is equal to minus of VBA. And most probably, suppose rain is falling down and a person like rides a bicycle and against the rain. Now, what we feel that the rain is exactly striking us, but really the rain is falling down. The rain speed or what with respect to us can be calculated. The rain speed with respect to a person or a rain speed with respect to a bicycle can be written like VR minus VB. Here like VR minus VP person. Similar problem we can solve, we can understand very clearly how to find out one speed relative to other. See the simple problem. Rain is falling vertically down. Of course, rain is falling down only with a speed of 35 meters per second, and a woman rides a bicycle with a speed of 12 meters per second east to west. Now, what is the direction in which she holds the umbrella in order to protect herself not to wet? Let's see the directions first. East, north, west, south. Now, first drawing a simple diagram. Rain is falling down and she is moving on the bicycle. This is towards west, towards from the east direction. How to write this? Now, diagram is, this is VR, the value is 35 meters per second, and east to west, what is that? C is velocity of bicycle, velocity of the bicycle or velocity of woman. This is a vector diagram. Now, shall I make like this? If you understand this, this is called VR, and I am changing direction opposite to that. Will you agree? Shall I write it as minus VB? Left side VB, right side if you write, you can make it minus VB. Now, how to draw a diagram? This is a combination of vector. Vr plus of minus of Vb is equal to velocity of rain with respect to bicycle. What is the meaning of this? Just now we had seen velocity of rain with respect to the bicycle is equal to Vr minus Vb. Now we are in the forward order, minus Vb in the forward order, where resultant vector Vr be in the reverse order, right? Now this is the angle. What is this? Tan theta is equals to Vb by Vr. Theta is equal to tan inverse of Vb by Vr. So tan inverse of Vb, what is the Vb value? Bicycle speed 12 by 35. Now you use calculator, this is 19 degrees. Now she has to hold umbrella in order not to wet and protect herself. This is east and this is west. They're simple. Earlier this is the straight direction of umbrella. Now what you will do? Just you turn towards west so that she cannot wait. Now this is the direction towards the west, making 90 degrees with vertical, so that she can protect herself from the rain by using umbrella. Now a very important topic, that is a body which is thrown in the upward direction and which is in flight, and we shall observe what is the maximum height that has been gone and what is the time taken to reach the ground again, where you have thrown a body like a baseball or a cricket ball or any type of a ball or object thrown in the upward direction. What are the parameters and how to analyze the motion? What are the accelerations, the vertical component of acceleration and horizontal component of acceleration, how to find those, we shall see one by one. What is meant by a projectile? A body which is being thrown and which is in the flight, which is also called as a projectile. Means a body thrown in the upward direction other than straight, which is in the air. We can analyze it in two-dimensional motion. See, simple understand, this is a reference frame, x-axis and y-axis. A body which is thrown with the initial velocity, we can call it as v0. This is called as v0, velocity where the body thrown with making an angle, initial angle, which is called theta naught with the horizontal. So that what happens, body will go, and this is the path generally, and the path can be also found from this. Now what happens, if you see that the horizontal component of initial velocity v naught cos theta naught, and this is called as v naught sin theta naught. These are the initial components of velocities, and the starting origin 0, 0. At a time t is equal to 0, the initial coordinates of the projectile body is 0, 0. Right? Now we try to analyze what are the distances traveled in the x direction, y direction, where it is traveled in the particular path in terms of time. See how to analyze it, how to see this. At 0, 0. When the body thrown with v naught, with making an angle theta naught, so that it goes maximum height and trying to reach again same ground like this is. So when you see that this is, again we can divide into components, and this is a velocity, divide into components, and this is a maximum height. This is called as maximum height, right. Here if you observe it, the horizontal component of velocity remains same. This is called V naught cos theta naught, and V naught cos theta naught, and V naught cos theta naught. Here the vector like this one, and this is V naught cos theta naught. Horizontal component of velocity remains constant, vertical component of velocity changes. At maximum height, the vertical component of velocity becomes 0. And when you consider the horizontal component of velocity is same, horizontal component of acceleration becomes 0, and vertical component of acceleration is equal to g. Now we will write it also. Here horizontal component of velocity V naught Vx is equals to V naught cos theta naught remains unchanged. So Ax is equals to 0. When there is no change in velocity, obviously acceleration becomes 0. Now here when you go through the path, slowly the V value means velocity value changes. Here only the horizontal component of velocity is present, vertical component of velocity becomes 0. Due to this, because of the velocity of horizontal component, then it has been thrown and it goes through the path like this. Otherwise what happens, if the velocity, total velocity becomes 0, the body should fall down like this, but you never observe this one. Body goes down and reaches to the ground, and this is like a parabolic path. Mathematically we have to see how the parabolic path can be observed. And moreover, here the initial velocity is there, and theta naught, as theta naught is changing and V naught is also changing, both are self-adjusted, and throughout the motion horizontal component of velocity remains constant. And vertical component of velocity Ay is equals to minus g, which is gravity. In the last chapter I think you had seen why minus g can be taken. The negative direction, negative y direction will take it. Now how to calculate the horizontal distance and vertical distances, so that we will write a proper notation. So horizontal distance, what is meant by a horizontal distance? And here horizontal distance, x is equals to horizontal component of velocity V naught cos theta naught and time traveled t. So now x is dependent on time. As time changes, x is also changes, right? You can treat it as equation number 1. How this was written? Generally in the last class we had learned it. X is equal to x naught plus V naught xt plus of ax t square, and this x naught is equals to 0 and ax is equals to 0, because x naught is the initial coordinates or the initial displacement at t is equal to 0, x naught is 0. So I am writing it as x naught is equal to 0 and y naught is equal to 0 here. The same can be applied, only we had observed it as V naught x into t. So V naught x is equals to again V naught cos theta naught into t. So t is equals to x by V naught cos theta naught. So keep aside, this will be useful to us. Now what is the y distance? Vertical distance with y is equals to y naught plus V naught yt plus of ay t square. Now y is equal to y naught 0 plus V naught sin theta naught vertical component into t minus of g t square. Ay is equals to minus g I have substituted. Of course, y is equals to V naught sin theta naught t minus of gt square, equation number 2. So I want to eliminate the time t, so that in place of t I would substitute t value which has been extracted from equation 1. I will substitute equation 1 in equation 2. How to write this? Y is equal to V naught sin theta naught, t is equal to x by V naught cos theta naught minus of g x by V naught cos theta naught whole square. Right? Now how to write this? So V naught gets cancelled. Y is equal to tan theta naught x minus of g V naught square cos square theta naught into x square. What is the form in general? This is, if you write it as y is equal to ax plus y is equal to ax plus bx square. If you write it, then what happens? A is equal to tan theta naught and b is equals to, you can write minus of g V naught square cos square theta naught. So what is happening? This is in the form of the equation 3. Equation 3 is in the form of y is equal to ax plus bx square, which is representing a parabola. Now hence the path of the projectile is parabola. Path of the projectile is parabola. Now we will extract certain relations from the projectile motion. What is the time taken from point of projection to reaching a maximum height, which is called as time of ascent? What is the time taken to reach the ground from the maximum height, which is called as time of descent? What is the horizontal distance that has been covered from point of projection to point of landing, which is called as R? This is called range. The total horizontal distance which is covered from point of projection to a point of landing. what is the total time that has been there in the air? A projectile like a ball has been thrown. How much time, how much duration, how long that is present in the air? That is called as a time of flight. So the amount of time that is present in the air, which is called time of flight. So H is there, TA, TD, range, time of flight. We will extract these relations from the derivations. Okay. Now time of ascent or time of reaching maximum height. First one, time of ascent, or simply you can understand time of reaching maximum height. Right. We apply the equations of motion in the horizontal direction and vertical direction. Here we observe and analyze vertical and horizontal components separately. This was actually proposed by Galileo, where horizontal component of acceleration and vertical component of acceleration, vertical distance, horizontal distance can be seen separately. So most of the times we use it as, first you understand x is equal to x naught plus v naught x t plus of a x t square here. Now y is equal to y naught plus v naught y t plus a y t square. In place of that one, I am writing a y is equal to minus g. These are helpful generally to derive maximum height or all the things. First one, the vertical component of velocity, we observe it. Vy, final velocity, Vy is equal to initial velocity plus Ay into t. Vy is equals to V naught y plus minus g into t. However, reaching a maximum height, I have written it as already 0 is equal to V naught sine theta naught minus gt. T is equals to V sin naught sine theta naught by g. Right? Of course, I am writing it as this is time of ascent, the reaching maximum height. Now, next, how to write time from maximum height to here? How to write that? Next, time of flight. How much time that is present in the air throughout the motion? Time of flight. We can represent it as capital T. So what is the meaning of it? It has to start from here and reaching to this one. Then what is happening? What is the displacement? A displacement again 0. Let's see, from here to here the total distance is r. Then how to write this? Y is equals to y naught plus v naught y t minus of gt square. See, here I am substituting y is equal to 0, vertical component of distance is 0 and initial component y naught is also 0. Substitute here. Now what you will get? 0 plus 0 is equals to v naught sine theta naught t minus of g t square. And shall I write it as in terms of t, the total time capital T? Is this okay or not? I am not representing small t, this one. Simply we will write it as sine theta into t is equal to half gt square. One tt gets cancelled. The total time is equal to 2v naught sine theta naught by g. So what you can conclude from this, actually you can also represent a time of descent, the moment, the time that has been taken from maximum height to this point is time of descent. Time of descent, you can write it, then this is equals to again V naught sine theta by G. Total time of flight is equal to time of ascent plus time of descent. You can simply write it as sine theta naught by G plus C naught sine theta naught by G. So total is equals to 2V naught sine theta naught by G. This is a time of flight. Now we shall see what is the maximum height and what is the range. Now, third one, maximum height, the expression for maximum height. Most of the times we will use it. Maximum height formula, we can write it as capital H. What is the maximum height? The moment the body has been projected from the origin or as a reference point, which is being reached to this point. What is the time taken? The time taken is time of ascent. So y is equal to y naught plus v naught yt plus half ayt square. What is the distance y? Y is equal to capital H. What is the y naught? Initial distance in y component covered is 0. And what is the initial velocity? V naught sine theta naught into t. What is the time that has been taken? That is time of ascent to reach the maximum point. Already we have derived just now, minus of g t a square. Right? Now just you substitute TA there from the derived formula, V naught sine theta naught. What is TA? V naught sine theta naught by G minus of G V naught sine theta naught by G whole square. Just you simplify it, you will get it. H is equal to V naught into V naught square sine theta to sine theta naught square, V naught sine theta naught square by G. Here again minus 1 G square cancel, and again you will get it as V naught square sine square theta naught by 2G. 1 minus half, like you can observe. If you take common V naught square sine square theta by G common, 1 minus 1 by 2, you will get 1 by 2. H is equals to, simply you will get V naught square sine square theta naught by G. This is called as maximum height. Maximum height. What is the angle at max? Suppose if you consider theta naught is 0, then what is happening? H is equal to 0. If theta naught is 0, H is equal to 0. Theta naught is 90, H is V naught square by G. Okay. Now what is to define range? How to define range? Range R. This is called R, the horizontal distance covered in total time. Horizontal distance covered in time of flight. What is the horizontal distance? R is equals to horizontal component of velocity into time. So simply again I am applying heat. See this, I am applying here. X is equal to x naught plus v naught xt plus of ax t square. X is, the distance is covered as R. Initial, it starts from origin 0, v naught x, v naught cos theta naught. What is the time covered? Capital T plus half into 0 into t square. Why it is 0? Horizontal component of acceleration 0, because horizontal component of velocity remains constant in the projectile motion. Throughout the motion also, the horizontal component of velocity remains unchanged. Now r is equals to v naught cos theta naught into simply t. Now you substitute v naught cos theta naught into t. What is t? Time of flight. Just you substitute here 2v naught sin theta naught by g. So v naught into v naught square, 2 into sin theta naught and cos theta naught by g. So what is meant by 2 sin theta cos theta? It's a sin 2 theta. Range is equal to v naught square sin 2 theta by g. Right? So this is a range, and we'll see the relation between maximum height and range and the relation between time of flight to the particular range. We will see that. Now, what is the relation between r and h without involving v naught? See, h and r. H is equals to v naught square sin square theta naught by 2g, and r is equal to v naught square sin 2 theta by g. Just from these two relations extract tan theta, then you have to prove it. Just this is for your space and you have to derive it. Just do the simplification. What is tan theta? From these two, tan theta naught is equals to, you will get it as 4h by r. Our initial projection angle is equal to tan inverse of 4h by r. You will have to see and simplify it. And what is the relation between the maximum height and time of flight? Maximum height and time of flight. This is time of flight is 2v naught sin theta naught by g. Now, how to write the relation between the maximum height and time of flight? The maximum height is equals to gt square by 8. Gt square by 8. You have to prove it. This is for your work to extract the relation or simplify the relation between the maximum height and time of flight, and the h and r. You can also write h and r. We can write it as 4h is equal to r tan theta. A simple problem, a Galileo, in which his book actually two sciences stated that for elevations which the exceeder are shortfall by 45 degrees angle, projection angle, by equal amounts, then ranges are equal. How it is analyzing? So what is ranges? What is a range formula? Just we had derived it. Range is equal to v naught square sin 2 theta by g. V naught square sin 2 theta by g. What is theta or theta naught, whatever it is? Theta naught is exceed of 45 degrees, let us say equal amount of angle alpha, or theta naught can be a shortfall by alpha, then substitute what you will get it. R is equals to v naught square sin 245 plus alpha by g. You will get it as v naught square sin 90 plus 2 alpha by g. Sin 90 plus theta, you can write it as cos 2 theta. R is equal to V naught square cos 2 alpha by G. Now for the other projection angle you substitute R is equals to here V naught square sine 45 minus alpha, less angle by alpha by G. R is equal to V naught square cos, sorry, here 2 alpha, 2 we have forgot. Now sine 90 minus 2 alpha by G. What you'll get? Sine 90 minus theta cos theta. Then you can observe it. V naught square cos 2 alpha by G. This is itself proving that both of the angles ranges are equal. Let's say simple alpha be the 15 degrees. Let's say alpha be the 15 degrees. Now what do you write? Theta naught is equal to first one 45 plus alpha is equal to 45 plus 15, 60 degrees. And other one 45 minus alpha, 45 minus 15 degrees is 30 degrees. Then substitute the 30 degrees there, substitute 60 degrees there, you will get same. How? The projection angle initially with 30 degrees, this is called as a projection, and other one 60 degrees, about this one 60 degrees, sorry. So both of the ranges are same. Probably what you can think of, the heights are different, but ranges are same for 30 degrees and 60 degrees. Okay, this is a simple proof of that one. Okay. And now a problem. A hiker stands on the edge of the cliff, which is at a height of 490 meters above the ground, and throws a stone horizontally with an initial speed of 15 meters per second and neglecting air resistance. If air resistance is considered, there is a slight change of values occurred. There is air-free environment you consider. Find the time taken by the stone to reach the ground and the speed with which it hits the ground. The first we have to draw a picture how it can be. Now this is ground. This is a cliff. Which is a height of 490 meters. Now this is a hiker here. Now hiker stands here. He throws the a stone. This is a stone. Right. Above the height, he stands on it and he throws it with horizontally with a speed of horizontal initial speed of V naught x is equal to 15 meters per second. When it is completely throwing in a horizontal direction, what is the velocity along y direction? Simply 0. Now after some time what happens? The ball reaches the ground. The ball reaches the ground. The question is, what is the time taken to reach the ground, first one, and what is the velocity at a moment where it hits the ground? What is the velocity? This is now how to write this. First time, how to calculate time. V naught here V naught x is equals to 15 meters per second. However, Vx is also particularly 15 meters per second. Now, vertical distance y is equal to y naught plus v naught yt plus of ayt square. Now, what is the origin? What is the initial point? We choose this to be origin. This is origin 0 comma 0. X naught is 0 and y naught is 0 at a time t is equals to 0. Now below the origin, what is the distance? This is becoming negative. Above the origin, the distance can be positive. Below the origin, it can be negative, which is called as minus 490 is equal to 0 plus v naught y. What is v naught y? 0 into t plus half into minus g t square. So, you will get it as minus 490, which is minus of gt square. Now, substitute g is equal to 9.8 into t square. Now, you will get it as t square is equal to 100 and t is equal to 10 seconds. First one, the time taken to reach the ground is about 10 seconds. Now, what is the velocity here? What is the velocity? Initially, the y component of velocity is 0, but here the y component of velocity is not 0. See that if you consider this one, this is a vector and this is vy and this is vx. Now, final velocity vy is equals to v naught y plus ay into t. Now, vy is equals to v naught y minus gt. Then, what is vy? Vy has to be calculated. V naught y is 0 and minus 9.8 into 10. Vy is equals to minus 98 meters per second and Vx is equals to 15 meters per second. Here, what you can write the v velocity? The v velocity is equals to under root of Vx square Vy square. Now, how to write this here? The velocity v is equal to under root of 15 square plus minus 98 whole square. You will get it as 99 meters per second. The moment where the stone hits the ground, the final velocity before hits the ground, as a moment it hits the ground, which is called as 99 meters per second. A problem. Here a cricket ball is thrown at a speed of 28 meters per second, making an angle 30 degrees with the horizontal. Then calculate the maximum height. Time taken by the ball to return the same level means time of flight we have to calculate. And the distance from the thrower point where the ball returns to the same level. See how to draw a picture diagram. This is origin 0, 0. Now a ball has been thrown. The ball has been thrown with a speed of 28 meters per second, making angle 30 degrees. So this is called V naught. V naught is equal to 28 meters per second. Now theta naught is equal to 30 degrees. V naught is equal to 28 meters per second. Now first what we have to calculate, what is the maximum height reached by the cricket ball? If you observe it, this is maximum height. Now what is the formula of maximum height? Maximum height is equal to V naught square sine square theta naught by 2g. Substitute g is equal to 9.8. So you can write 28 square sine square of 30 degrees by 2 into 9.8. So h is equals to 28 into 28 into 1 by 4. Again it is 19.6. Average, you calculate it, it is a 10 meters. Next, what is the time taken to return the same level? The wall has been started from here and reaching the point that is a level. So what is the total time? That is total time, which is called as a time of flight. B. T is equals to 2V naught. Here the time of flight to be considered 2V naught sin theta naught by G, which is equals to 2 into 28 into sine theta 30 degrees by 9.8. If you calculate it, approximately this is 2.9 seconds. Now third one, the distance through from the point, this is called from point of projection, to reach the same level, this is on the ground level, this. So total, which is called as range R. What is the formula for range? V naught square R is equals to V naught square sine 2 theta sine 2 theta by G. R is equals to 28 square sine 2 into 30, 60 degrees. Otherwise, I am writing 2 into 30, 9.8. R is equals to 28 square into sine 60. It is about root 3 by 2 by 9.8. If you calculate it, approximately it is 69 meters. So this is to calculate a range, a maximum height, time of flight, and sometimes they may ask relation between maximum height and time of flight.